Okay, so here we have the sum as k goes from 0 to 20 of 1/4 times 3/5 to the k. So immediately from this, I recognize that my a number is 1/4, and the ratio I'm dealing with here is 3/5. Okay, so that's the first things I recognize. Okay, I see my sum is starting from 0 to 21, or 0 to 20. So the terms I'm adding up look like this. 1/4 plus 1/4 times 3/5 plus 1/4 times 3/5 squared, and so on, coming all the way up to k equals 20. 1/4 times 3/5 raised to the 20th power. Okay. Realize that this is s sub 21. S sub 21. All right, this is sum from 0 to 20. That's going to be s sub 21. Okay, so that's what we have to use n equals 21 when we pull in that formula. So s sub 21 is going to be a 1/4 times 1 minus r to the n, 1 minus 3/5 to the 21st power, and that's divided by 1 minus 3/5. Okay. Now this one here, I'm going to just approximate. I don't want to deal with, we could, but it's going to be kind of messy here. 5 to the 21st power, right? Being something messy in scientific notation like that, so I don't want to deal with that. So I'm just going to approximate this on my calculator. 1/4 times parentheses 1 minus 3/5 raised to the 21st power. That's my numerator. Divided by 1 minus 3/5. Okay. So we get 0.6249 and so on. I don't know if my calculator can even convert that correctly to a fraction or not. So I'm just going to round off and say that's roughly 0.625. It's roughly 0.625. Okay. Like I said, I don't know. My calculator will convert over to a fraction, but I don't know if that fraction's actually accurate. Probably isn't on this calculator for sure. Definitely, it probably isn't on this calculator for sure, right? Because it's doing 917. That doesn't sound right in things that would have been in terms of fifths. So mine's off by doing a rounding error. Now, on your graphic calculators, they store things a little bit deeper. So if we try this, excuse me. Sorry there for a second, I had an ad pop up, so it's a problem with doing this app with the free version. So if we did this again, I think my calculator here might be able to do it a little more accurately, because again, these calculators store things, but 5 to the 21st power is a pretty big number. Yeah. So, but we'll see what the calculator says here. So that would be 1 minus, again, 3/5 raised to the 21st power. Close those parentheses. Divided by 1 minus 3/5. Okay, so, and there's my decimal, and I'm just going to see what it says as a fraction. Yeah, you can see why we don't want to deal with fractions. That's a really, really ugly fraction. And again, I'm not positive that it's even doing this exactly. It could also have, this calculator could also have some rounding involved. And I say that because that denominator there It just doesn't seem like a good denominator that would go with something that's in terms of fifths. So that's why I'm kind of suspecting that there's even some rounding off here. Okay, so because of its being so big, I'm not going to worry too much then about the thing. So I just approximated here. So really I should say is approximately 0.625. Okay. So that's what would happen if you're dealing with a bigger one. Now, you will see some sums in the homework where it'll be very similar to what I just did, except the sum won't start at 0. The sum won't start at 0. So what if we had this problem here? Exact same problem. Sum as k goes from 5 to 20. Then you actually have a couple of options. You actually have a couple of options here. You could say, well, this would be the same as the sum as k goes from 0 to 20 of 1/4, 3/5 to the k, minus the sum as k goes from 0 to 4 of 1/4 times 3/5 to the k. And so you can do it this way, and then you compute this as S21, like we just did up above. You would compute this, since it's going to 4, as S5. So you would use the same idea, and then once you compute S21 minus S5. That's one way that you could do the problem. That's one way that you could do this problem. Okay. There are other ways to do it, but that's probably the simplest. Is if you have a sum that's not starting at 0, like it's starting at 5, then realize that that would be the same as taking the sum from 0 to 20, and we're removing from 0 to 4. Okay, and we would just compute S21 minus S5 in this case, because it's a sum going to 4. Okay? So that's what you would do if you were dealing with a bigger one. I'm not going to actually compute it, but you can kind of see how we would do that now if you run into ones like that.